if we sail a little bit high?
Your hair stand on end after combing it, or after you've rubbed a rubber balloon against it. This video will look at the physics behind static electricity. It might help you if you first viewed the video on atomic structure. Current electricity is a relatively recent discovery, whereas the effects of static electricity were written about over 2,000 years ago in ancient Greece. As the name static electricity suggests, it is static, it doesn't move. Metals allow the flow of electrons in current electricity, but here we are dealing with all the other materials that are not metals and are insulators. If two different non-metal insulators, a cloth and a glass rod for example, rub against each other, then both may become charged by friction. As they rub together, electrons may be removed from the surface of one and deposited on the surface of the other. Once there, the electrons cannot move, they are static. Since all materials are naturally electrically neutral because they have an equal number of protons to electrons, this transfer of electrons leaves one material with less electrons and less negative charge than it had before, and the other material has more electrons. So one of the materials becomes positively charged and the other is negatively charged. This can be seen when a plastic rod, such as a ruler, is rubbed with a soft cloth. Electrons may be transferred from the cloth to the ruler. If two identical rulers are charged in this way and one is suspended in a simple cradle as shown, as the end of one ruler is brought closer to the other, repulsion is seen as the suspended ruler turns. It is pushed away. Holding the cloth used for charging near to the ruler will attract it toward the cloth. This shows that there are two types of charge, positive and negative. So alike charges repel or push each other away, whereas opposite charges attract each other or move towards each other. Which material becomes positive or negative depends on the identity of each. This happens when you brush your hair. The brush and the hair take on opposite charges and so become attracted to each other. There may even be a crackle, and in a darkened room you may see tiny sparks as the electrons jump the small gap to make the materials electrically neutral once more. This often happens when removing clothing made of certain fabrics. This is a party trick where a rubber balloon, after rubbing against a cloth or a jumper or even someone's hair, can be made to stick to a wall. This works as the charge given to the balloon, let's say is positive, when brought near to the wall causes or induces a slight charge separation in the wall as negative charge is attracted towards the surface. This induced slight negative charge is sufficient to attract and hold on to the positively charged balloon, so it sticks. Even holding a freshly charged plastic comb next to a thin stream of water from a tap shows a similar effect, that of induced attraction. The slight spark caused by the electrons jumping from one material to another can be dangerous. Petrol and other liquid fuels build up a static charge as they flow through a plastic pipeline. There is an earthing cable connected to the fuel nozzle at a garage, and aeroplanes are linked via a similar cable during fueling to prevent a static spark igniting the fuel and causing an explosion. So the next time you drag your rubber shoes across a carpet and then touch a door handle or your friend, and you hear a click and feel a small shock, you know that you have just witnessed static electricity in action.